and then finally we have 9. Okay. Now what we're going to do from a process perspective is we're going to go to the next largest size sets, which are sets of size 2. But to do this, what we're going to do is we're going to go back to our singletons, the first singleton that we identified, and we're going to pair its element off with another element out of the set B. And actually I like to work from left to right, okay? So we'll take the singleton, which is the set that has a 2, and what we'll do is we'll pair it off with a 7, okay? Then we'll take the singleton, which is a 2, and we'll pair it off with the 9, okay? We pair it off with the 9. And we stop when there's no possible pairing to the right hand side, no other pairing that we can do to the right hand side with respect to our original singleton. Then we move on to the next singleton, which is 7, okay? And we pair that off with another element in the set. Now, I could pair 7 off with 2. Well, that'll give me the set that contains the elements 7, 2. Okay, but that's already been included. Okay, so what we need to do is we need to pair 7 off with what's on his right hand side, which is pairing 7 off with a 9. Okay, and that's the next possible pair that we could have. Then we take the 9. Okay, well, what other element could I add in with the 9? I could add in a 2. Okay, with the 9, but we've already got 2, 9. I could add in a 7. So I'd have 9, 7, but I've already got 7, 9 here. So there's no other possible value that we can add into this particular singleton that will give us a set of size 2 or of cardinality 2 that hasn't been listed previously. So actually, these are all the sets of cardinality 2 that we could construct from this particular set. And then finally is our set of size 3, and the only set of size 3 that is a subset of B is itself. So what we do is we put in 2, 7, and 9, and this gives us our power set. Okay, and let's do one more example. Okay, let's take a set of size 4 and let's see how we get on with that. Okay, so let's take a set of size 4. So let's say the set C is equal to the set that contains the values 2, 7, 9, and let's say it contains 3 as an example. And what we want to construct here is we want to construct the power set of C. So we're going to construct the power set of the set C. And like the way we did in our previous example, what we start off with, well, the power set is a set, okay? And we start off with the smallest possible set that we could have from a cardinality perspective, which is the empty set. So the empty set is going to be in this set. Then all possible singletons. So we have the set that contains 2, the set that contains 7, the set that contains 9, the set that contains 3. You can see with the singletons, all I've done was created sets from all of the elements within the original set C. Then we start with the pairs, the sets of size 2, of our cardinality 2. I take my first singleton and I add in one of the other possible elements. So 2 gets paired with 7. Okay. Then we take 2, and 2 could get paired with a 9. Okay. 2 could also get paired with a 3, and there's nothing else to pair 2 with. So at this stage we've exhausted this singleton here and expanded it to sets of cardinality 2. We take the next singleton, which is 7. Okay, so we have 7 and we throw in another element. So we could throw in 2, okay, but we've already done 2, 7. Okay, so we always go to the right hand side. So 7 gets paired off with a 9. Okay, there we go. 7 gets paired off with a 3. So we have 7 gets paired off with a 3. And there's nothing else that we could pair 7 off with in this set that hasn't occurred already. Then we take our next singleton, which is 9. Okay, so we take 9 and we pair 9 off. Well, we always pair to the right, so 9 gets paired off with a 3. And there's nothing else to pair 9 off with. Then we take 3. Let's see 3. 3 could get paired off with a 2. But we've already done that, the 2, 3. 3 could get paired off with a 7. But we've already done that, the 7, 3. 3 could get paired off with a 9. We've already done it, the 9, 3. Okay, so actually there's nothing to pair 3 off with on its right hand side, so we don't include that. So now that we've done all sets of cardinality 2, we now move on to cardinality 3, where we take our first set of cardinality 2 and we start adding in other elements from our set. So we'll take 2, 7 as an example. So we take 2, 7 and we add in another element. Let's add in the 9. There's a set of size 3. Let's take 2, 7 again, and this time let's add in the 3. Once again, you can see the pattern here. You can see the process. You can see the algorithm, hopefully, is that every time we take our pairs, we always pair off with the right-hand side. Okay, so that's 2, 7 done. Now we take 2, 9. So 2, 9, and we pair 2, 9 off with everything else. So 2, 9, well, we could throw in a 7, but that would give us 2, 7, 9, which we've already done. So the only thing to pair it off with is the 3. So 2 and 9 gets paired off with what's to its right hand side, which is a 3. Okay, and there's nothing else to pair 2, 9 off with, okay, because we've exhausted all the elements to the right hand side of the 9. That's 2, 9 done. Then we take 2, 3, but look at 2, 3. There's nothing to its right hand side, okay, so there's nothing to pair it off with. If we consider 2, 3, and 7, well, we've already done it. We've got 2, 3, and 7 is here. If we consider 2, 3, and 9, well, we've already got it. There's 2, 9, and 3. So we've done all sets now of size 3. And then we move on to, well, 2, 3 is done. What about 7, 9? Well, considering 7, 9, there is a possible pairing to the right. It's with the 3. So now we have 7, 9, and 3. Okay? There's nothing else that 7, 9 could get paired off with. Well, we could pair it off with the 2, but that would be a 2, 7, 9, which we've already done. So once again, the key thing here is to keep pairing off to the right hand side. Okay? So now that we've done all sets, that's the 7, 9 is done. What about the 7, 3? Well, 7, 3 is here. There's nothing to pair off to the right, so that's done.